Navigating the challenges of unstable soil, the construction of the Markthal in Rotterdam reflects the commitment to modern architectural innovation. After laying 480 tons of reinforcement, 1.5-meter thick underwater concrete floor was poured and allowed to harden. Once the concrete set, the water was carefully pumped out, employing impermeable barriers and dewatering solutions to reveal a smooth, watertight floor capable of supporting up to 12,000 kilograms per square meter. With the foundation laid, the project moved upward to construct the unique horseshoe structure using the tunnel formwork system. Building the arch roof was a notable engineering endeavor, supported by temporary, mobile shuttering to accommodate the apartments and penthouses. Inside, the market hall features the Horn of Plenty artistic ceiling that spans 11,000 square meters, adding vibrant artwork to the space. The Markthal seamlessly blends market and residences with single glazed cable net glass facades, enhancing transparency and connection to the city. Having tackled the foundational hurdles this week, we now move forward to explore the architectural feats involved in crafting the arch and keystone. The Markthal's structural design exemplifies an advanced integration of architecture and engineering, rooted in a thorough understanding of geotechnical conditions and executed through a monolithic approach. Supported by approximately 2,500 piles driven 20 to 30 meters into sandy subsoil, the 500-millimeter thick concrete floating foundation responds elastically to differential settlement and groundwater pressure, enabling the building to adapt to Rotterdam's soft, compressible soils and high water table. This foundation not only bears vertical loads, but also works in concert with the underground parking level, which acts as a horizontal tension tie, bracing the arch and resisting lateral soil pressures. Rising 40 meters high and spanning 45 meters wide, the arch-shaped superstructure forms a continuous load-bearing shell through the seamless integration of core walls, shear walls, slabs, and the basement floor, avoiding the weaknesses of segmented construction. These elements collectively distribute loads and resist both vertical and horizontal forces, with the upper residential levels functioning as keystones to stabilize the arch. Built using in-situ concrete rather than precast components, the Markthal achieves both structural integrity and visual impact, demonstrating how monolithic design and elastic foundation strategies can deliver resilient, elegant solutions in challenging geotechnical environments. The core walls and shear walls serve as the principal vertical load-bearing systems, channeling gravitational forces from the top of the arch to its foundation. Meanwhile, the floor slabs, constructed with tunnel formwork, provide horizontal stiffness and tie the vertical walls together, enhancing the building's lateral stability. This system not only supports vertical loading but also resists horizontal and torsional forces, ensuring equilibrium within the arch structure. Tunnel formwork is a construction technique primarily utilized for structures requiring repetitive and uniform units, such as apartment complexes, hotels, and barracks. This method leverages prefabricated forms or molds to create walls and slabs in a single process, significantly enhancing construction speed and efficiency. The process allows continuous casting of concrete, integrating structural elements seamlessly into a cohesive, monolithic framework, which is particularly advantageous for large-scale projects requiring rapid completion and cost efficiency. In the construction of the Markthal in Rotterdam, tunnel formwork was adapted to accommodate the building's unique horseshoe-shaped arch structure. The methodology facilitated the efficient construction of repeated structural cells that form the arch, incorporating both vertical core and horizontal slab elements. Tunnel forms were positioned to support the simultaneous casting of walls and slabs, moving incrementally inward with each ascending floor. This allowed for the gradual narrowing of the gap between the arch sides. A single operation involved pouring concrete for walls and slabs, using internal vibrators to ensure even distribution and density. The cycle was repeated in 3-day increments, facilitating continuous progression and structural integrity. The cores provided lateral resistance and were constructed synchronously with the tunnel formwork, ensuring alignment with the progressing arch and maintaining monolithic continuity. The slab and wall integration using tunnel formwork eliminated seams and weak points, creating a unified structure capable of bearing substantial loads and pressures distributed evenly across the arch. In large arch constructions, such as the Markthal, shoring or temporary support structures played a crucial role. These supports, including steel trusses and brackets, were essential at various construction stages to stabilize formwork and platforms, especially where there were no concrete cells below to provide support. Temporary steel shoring supports were strategically placed to stabilize platforms and load concentrations, particularly in areas with complex curvatures and those lacking foundational support. Load distribution. These supports were designed to evenly distribute loads across unstable sections, enhancing safety and maintaining structural integrity throughout the construction process. The keystone was a pivotal element in the completion of the Markthal arch. This crucial part connects the two lateral arches, ensuring structural equilibrium. The construction process culminated with the placement of the keystone at the apex of the arch. This section, approximately 5 meters high, integrated floor slabs, walls, and roof slabs into a continuous structure. Structural function. Acting as the arch's central locking piece, the keystone consolidated the structure under compression, allowing the adjoining arches to balance each other. This effectively transformed the arch into a stable, self-supporting entity, eliminating the need for additional central columns and enhancing the open spatial concept beneath. The application of tunnel formwork in the Markthal not only facilitated its construction efficiency, but also ensured its resilience and architectural symmetry. Integrating core structures and slabs into a monolithic design while utilizing modern shoring techniques and the strategic incorporation of the keystone exemplifies the innovative approach undertaken to erect this iconic edifice on challenging terrain, solidifying Markthal's place as a landmark of modern engineering and design. This week, we focused on the construction of the monolithic arch to cable facade and ventilation, heating, tunnel formwork system to mobile stuttering system, and completed with a central keystone. Next week, we'll explore the main hall, which features a naturally ventilated system where air flows in through the glass facade, rises, and exits via ventilation shafts, creating a self-sustaining thermal environment. The Markthal stands as a testament to innovative, sustainable architecture, blending functionality with environmental consciousness.